Oxidation state of D block elements. This is very important for our short answers and very short answers. So you in a question of 1 mark you have, and 2 marks and 3 marks are short answers or 2 marks, and very short, I mean this is a short answer, and very short answer is 2 marks. So in this out of short answers, very short answer, they will ask you this oxidation state of D block. Explain why D block elements exhibit variable oxidation state. I told you in the introduction side, I mean characteristics of transition elements, I said each and every points are one now grid explanation to be explained. So why variable oxidation state? 1 now, 3 marks or 2 marks they will be asking you. It is reason you are supposed to apply. After applying, writing the reason, you should give one example. So what if it is a 3 marks, 1 mark and a example another 1 mark. Otherwise you will lose your 1 mark very easily. So this is due to the D block elements have several n-1d and ns electrons. Second point, that is called D block elements have several n-1d ns electrons, I said, for the first reason. Second thing is the energy between n-1d and ns orbitals are very close to each other. First thing is electron, second point is orbital. So n-1d and ns electrons, it has several things. And energy of n-1d and ns orbitals very close to each other. The example is Fe2 plus and Fe3 plus. This is one 3 mark question or a 2 mark question. Let us see the minimum oxidation state and maximum oxidation state. O is for oxidation state. Minimum oxidation state, maximum oxidation state. Minimum oxidation state due to the number of electron in ns orbital. Maximum oxidation state is due to number of electrons in both ns, I mean ultimate shell electron as well as the penultimate shell electron. So ultimate shell is called ns valence shell and n-1d orbital is called a penultimate shell. These two electrons are calculated by saying maximum oxidation state. I mean from here only the number of electrons will be losing. So what it is a maximum oxidation state. Minimum oxidation state only the number of electrons in the ns orbital. Maximum number of oxidation. You please listen this sound, all the key points, and it is giving what acidic nature, basic nature, ionic character, covalent character, amphoteric nature. Everything is based on the lower oxidation state and the higher oxidation state. Key points, bullet points you study. So arrow marks and all, it is called bullet points only. So maximum number of oxidation state occur either inside or near the middle of the series. The near the middle of the series means what are chromium and manganese, like this molybdenum, like the tungsten. These period, this is called the first transition, I mean first elements and middle of the elements and the last of the elements. When you compare here, first and last elements will have fewer oxidation state, but in the middle of the series will have the maximum number of oxidation state. That is what I have said. Maximum number of oxidation state occur either inside or near the middle of the year. And 3D series, manganese is +2 to +7, middle of the series. And the beginning and the end of the series exhibit only fewer oxidation state. Let us see one example. You just see this. Okay, let's see this question. In this question, you just see this scandium, titanium, vanadium, chromium, manganese, like that. Manganese, iron, copal, nickel, and copper, zinc. Like that, you can write like this. Have it done. Scandium only +3, and +2, +3, +4. And you just see ending and I mean initial and final. We are getting only fewer oxidation state. But in the middle only we have a maximum oxidation number. That too, manganese as a +7 oxidation state. So this is the meaning of in the beginning of the elements, fewer oxidation, and the ending also fewer oxidation. Only at the middle we have a maximum number of oxidation. So is the meaning of writing this maximum number of oxidation state occur either in or near the middle of the series. But near beginning and the ending of the series, exhibit only fewer oxidation state. So maximum number of oxidation state in 3D is manganese having +2 to +7. That means +2, +3, +4, +5, +6, +7. Gradually increases by 1, 1, 1 to +2 to +7. So it has a maximum number of oxidation state in the middle of the cells. So in transition elements, we have lower oxidation state and higher oxidation state. Lower oxidation states are +2 and +3. That forms ionic bonds. That all metals will form ionic bonds. But higher oxidation states are formed covalent bonds. Remember this, lower oxidation states form ionic bond. Higher oxidation states are formed covalent bond. The +2 and +3 will form an ionic bond. Beyond 3, 4, 4, 5, 6, 7 or form a covalent bonds. And highest oxidation number in transition metal is +8. In the beginning of general electronic configuration and lyrics of D block elements, I told you ruthenium and osmium has a maximum oxidation number is +2, +8. These two are alone having +8. They will ask you in a 1 mark question. Ruthenium and osmium has +8 oxidation state, maximum oxidation state. Here the transition metal shows 0 oxidation states in compounds. So this is called nickel, CO4 carbonyl groups. Tetracarbonyl nickel, Roman letter 0, 0 oxidation state, because already explained coordination compounds would have a 0 oxidation because it's a neutral ligand. So 4 into 0, 0. So it has the 0 electronic configuration. 0 oxidation state. The rule I told you, 4 rule you are supposed to follow in coordination compound by naming. First number we should say tetra. Then ligand, name of the ligand. Second one is name of the ligand. That is carbonyl. That is tetracarbonyl. Third thing is central metal ion name, nickel, whether anionic complex or cationic complex, we should see. If it is an anionic complex, means it should be ended by 8, nickelate. If it is minus is there, nickelate. If it is minus here, ferrate. These are the Latin names. If nothing is there, we should say ordinary name, nickel. First one, numbering, number. Second one, ligand name, tetracarbonyl. Next one, central metal atom or ion name, that is nickel. Next, followed by the oxidation number of central metal atom, that is neutral ligand 0, 4 into 0, 0. So the oxidation state of nickel is 0. Similarly, here tetracarbonyl ion 0 oxidation state enclosed in closed bracket. So it is because neutral ligand 0, 0 into 4, 0. So that oxidation state of ion is 0. So in a brief, I have explained in a coordination lesson. You just to see how to find out the oxidation number of central metal. So this is a 0. So that this complexes and this complex have a 0 oxidation number. So iron, nickel has a 0 oxidation state in compounds. Thanks for